Hey guys, thanks for watching my channel. This is the section 2.4 video. We're writing equations of lines today. The essential question is, how can I write equations of lines in slope-intercept form, point-slope form, and standard form? We have three different forms we need to know. Here they are. I would highly recommend you put this into your notebook, and I would highly recommend that you memorize these. They're actually over on the wall in class, but they will not be there on the tests and quizzes. Now, slope-intercept form. This is the one that you're most familiar with. Remember that the M is slope and the B is the y-intercept. That's the one that you've done a lot. The one that students hate, mostly because it's not used as much and usually it's a form that you don't see as much, is point-slope. But by George, is it useful. Slope is still the M. But instead of having to solve for the y-intercept, which you often have to do, all you have to do is plug in a point. This x1, y1 is just a point on the line that you are typically given. Again, this x and this y stay in the equation because it's an equation. You need an x and a y. But the x1, y1 is a point. Standard form is maybe even more loathed than point slope form, and that's because it's just kind of hard to work with. You have this A, B, and C, and if you watch the previous video, you know that these don't really directly mean anything like a slope or a point. They're just there because of the way the formula is arranged, and rather annoyingly, for standard form, we require these to be integers, and we'll see how that looks when we get to example number 4. So again, it's very good to memorize these forms so that you don't have to look back in your book. Here's a picture of a very successful looking African-American man looking back in his book because he didn't memorize his formulas. He would be even more successful if he memorized them. So don't be this guy. Memorize your formulas so that you don't have to look back in your book for them. So example number 1, we're jumping right in. We want to write the equation of a line in point-slope form. It passes through this point and it has a slope of 1/2. Now this is brilliant. They've given me literally exactly what I need in point slope form. Remember, point slope form is y minus y1 equals m x minus x1. And oh my goodness, I have my point. Here's my x1, y1. I have my slope. I can just plug in the values and I'm almost done. So y minus my y1, which is 1, equals m 1/2 times x minus x1, which is 4. So that's an equation of my line. I'm already done. Typically, though, we like to isolate the y. It's very good to isolate the y. For this problem, I suppose you wouldn't need to because it does say write the equation of a line in point-slope form. So this would be my final answer, but I'm going to show you how to isolate the y because we'll be using it later on. To isolate the y, first I'd probably distribute the 1/2 through. So y minus 1 equals 1/2 x. What's 1/2 of -4? Oh, -2. Whenever you're multiplying something by a half, just think literally what is half of that number. And then finally, I would add 1 to both sides, so y equals 1/2 x minus 1. This would be the equation of the line in slope-intercept form, and sometimes I'll ask you for that. All right, the next example, they're saying write the equation of a line that passes through -3, -5, and is parallel to this other line, y equals -4x plus 1. Now, students typically get really confused with questions like this because they're like, hey, mister, do I plug in this -3 for the x and then this -5 for the y, but it doesn't work and what happens? And you're kind of missing the point of the problem. Also, your voice sounds stupid if you ask me like that. What you need to do for the problem is just like we did for example number 1. I'm given a point. I'm also given a slope. Can you find it? If I'm writing the equation of a line that's parallel to this line, what do we know about parallel lines? They have the same slope. So my new line is going to have the same slope as this old line. Both lines are going to have a slope of -4. So the problem actually gave us the slope, We just had to find it in the old line that I know is parallel to the new line I'm going to make. So let's go ahead and make that new line. And I think the easiest thing to do, since I'm given a point and the slope, is let's use point-slope form. Here's my x1, here's my y1, and remember the the point-slope form is y minus y1, which is -5, equals slope, -4, times x minus x1, which is -3. Now we have a bit of cleaning up to do here, and since it's just saying write the equation, I do probably want to isolate the y. It just looks nicer, and then you're ready to graph. First of all, let's cancel out some of these double negatives. Y minus -5 is the same as y plus 5. I know that x minus -3 is plus, and let's also distribute the -4 in. So I have -4x minus 12. And my final step would be just subtracting 5 from both sides, so that y equals -4x minus 17. You may have learned a method in previous classes where you did slope-intercept form, and that was, you know the slope is -4x, but then you still have to solve for b, and so you plugged in the point. So this point would go in for x and y, -5 equals -4 times x of -3 plus b. And then you know that -4 times -3 is 12. So hey, I just solved for the b through that way. And again, I went through that kind of quick, but this is another way you want to do it. If you want to start off in slope-intercept form, plug in your slope. That's what I did in this step. And then plug the point into x and y, because remember, this point is a valid xy coordinate value. You can use it to eliminate the x and y in the problem, just like I did in this step, and then just solve for b, the only unknown. And notice this b is the same as if I did point-slope form. You can use either way. I think going directly to point-slope form is the easier way. Let's look at example number 3. I want to write the equation of a line that passes through the points -1, 2, and 3, -4. Well, this is really great. I have 2 points to choose from that I can use as my point in point-slope form. Let's just use the one with smaller numbers, but a lot of times students are like, hey mister, do I use like that one or that one? How do I know? And either one works because they're both a point on the line. So as I'm starting to plug into my point-slope form, I have y minus y1 equals, shoot, what is the slope? I don't know that yet. Let's just leave the m in there, and x minus x1. Now, how do I find the slope? Oh wait, I have 2 points, right? And so I can use my slope formula. Let's use the correct slope formula, not the one that Mr. Regier shamed me for. So I have y2 minus y1 over x2 minus x1. This is already my 1 point. Let's make this x2 and y2. So I have -4 minus 2 over 3 minus -1. That would be -6 over 4, which reduces to -3 over 2. Hey, there's my slope, and I'm going to plug that bad boy right in there for m. He's not really a bad boy, he's a slope. That doesn't make sense. Okay, let's clean this guy up a little bit. We'll distribute in. We know that this double negative cancels, so on the right-hand side I have -3 over 2x minus, don't freak out about the fraction multiplication. 1 times anything is the anything, so 1 times -3 over 2 is just itself. I have y minus 2. Now I need to add 2 to both sides. This might freak some of you fraction haters out. You could probably do it on your calculator if you wanted, but since my slope is a fraction, just make sure this number is a fraction as well. It's going to make it look cleaner. -3 over 2 plus 2 with a common denominator of 2 is 4 over 2. See what I did there? I made 2 over 1 4 over 2 so that it has a common denominator. And -3 over 2 plus 4 over 2 is just 1/2. That's nice and easy. So here is my final answer. One last problem, and then I swear I'm done. Write the equation of a line in standard form that has slope m equals -3 over 2 and passes through the point 4, -7. Okay, great. So you know you're plugging this into the point slope form. Awesome. Okay, let's clean things up. So y plus 7 equals negative 3 over 2x. Doing the fraction multiplication here, I have negative 3 over 2 times negative 4 over 1. I know that the 2 and the 4 can pre-reduce to negative 2 over 1, so all I have is positive 6. That's nice. And I can subtract 7, so y equals negative 3 over 2x minus 1. But the bad part is I need it in standard form, and people hate standard form because you have to take this and make it look like ax plus by equals c. It's really, really awkward. People are like, how do I solve for the a, the b, and the c? And it turns out you don't, because take a look at what I can do. If I just add 3 over 2x to the other side, I'm kind of un-isolating the y. Don't I have 3 over 2x plus y equals negative 1? And this looks like standard form. Standard form just means get the x and the y on the same side. So this is really close to being the final answer because I have x and y on the same side. The only thing is, remember I said that a, b, and c have to be integers. Right now, my a value, the one that's next to the x, is definitely not an integer. So how do I get rid of it? Remember last chapter how we got rid of fractions when they're in equations? I multiply by the least common denominator. That skill is going to be useful here as well. The least common denominator here is 2, so if I multiply my whole equation by 2, that should get rid of the denominator and give me all integers. So 3 over 2x times 2 is 3x, the 2's cancel. 2 times y is just positive 2y, and 2 times negative 1 is negative 2, and would you looky there, I have standard form. My a, my b, and my c are all integers. The x and the y are on the same side of the equation. I am donezo. Summary. Memorize your line equations. Don't have to refer back to them all the time. It will save you time, and knowing them will tell you what information you need to find the line. Do I need the slope? Do I need the x1, y1? Do I need to get the x and the y on the same side? So memorize those. Thanks for watching, guys.